This is Josh White with JW Math Tutoring. In this video, I'm going to go over 13 problems from the March 2026 Digital SAT Math exam. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Before I get started on these March 2026 Digital SAT math problems from worksheet and video number 2, I just want to mention a couple of things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, make sure that you watch the video for worksheet number 1, which has 13 new problems, and also the video for worksheet number 3, which basically has all of the repeat questions, meaning questions I've covered before, sometimes in multiple previous videos. So make sure you check both of those out. Other things to mention, I have tried to kind of reconstruct or reverse engineer these questions as best as possible. I've tried to make them workable, but it is possible that the question I have designed might have, minor differences from one that you received on the official exam. Okay, so if there's something that comes up like that, feel free to, to point it out. But otherwise, like I said, I've tried to do my best to make sure that these questions, accurately represent what students saw on the March 2026 exam. Okay, so with that being said, I think that's, also, sorry, just to mention, link to the worksheet with all the problems on it will be in both the description of the video and also in the pinned comment as well. All right, so question number 1 here. All right, this factoring question was covered previously way back in November of 2024, but I did want to revisit it and highlight it again here. Also, this question was covered in my Ultimate Desmos Guide to Digital SAT Math, specifically the video, I think it's part 14, that deals with factoring. There was an example practice problem in it that was identical to this. It just had different numbers. So just be aware of that. If you're not checking out those resources, you should be, because if you had, you would have known exactly how to do this question. You would have gotten it correct, and you would have not been like all the other people online, basically wondering how to solve it or not knowing any idea how to figure it out. Okay, so what's going on here basically is we have this 4th degree polynomial. It's being factored, the way as a trinomial, and there's 2 different factorizations that work out. One of them has integer numbers, just like we're normally used to factoring. The other one does not have integer numbers, has non-integers. Okay, so there's multiple ways you could do this. First, I will show you the quickest, easiest way to do this in Desmos. All right, and that is going to be to do the following. I'm going to basically take the original expression and I'm going to equate it to the factored expression. Okay, using regression. Let's slide this over. Okay, I need my element list for x1. All right, so notice off the bat here, it's technically giving me the non-integer values for B, technically it's for A and B here, but really we want C and D are the ones that are supposed to be non-integers. That actually doesn't matter in the problem. A and B versus C and D, it doesn't matter which is which. But let me just see if I can switch these and just to make sure everything carried through exactly as it should be. Okay, so it's giving me now here the non-integer values right off the bat. That's fine. Doesn't matter which one we start with. Okay, what I'm going to do is I'm now going to copy this. I'm going to duplicate it. I am not going to adjust the list. I am not going to change anything else in the regression, except I am going to switch the order of the parentheses. And so the 2x squared parenthesis is first, the 3x squared parenthesis is second, and I'm also going to now change the letters to A and B. Notice when I do that, it finds the second factorization. Therefore, we can now just go down here and do a plus c, and I get 33.5 or 67 over 2. So for this specific problem with these values, these are the two answers that you can enter, 33.5 or 67 over 2. Now let's talk about some other ways you could solve this, just to show you kind of the theory behind it. Okay, so just jumping back here into Desmos. One thing just to mention, I'm going to delete this temporarily, and now I'm going to copy it again. Okay, so now one thing I do want to show you is technically another way you could get the second pair of factors is you can put a restriction on here. Like let's make a less than 28, and notice when I do that, it now finds the integer factors of 5 and 19. Okay, so if you don't want to bother switching them, this is an alternate way you can do it. The problem is if you started with the integer factors of 5 and 19, you might not necessarily know which direction to go in order to get the other pair of factors to be like 28.5, 28.5, and 3.333. But in any case, this is an alternate approach you could take as well. Now, just to show you what's really going on here, and this will be the kind of the last thing that I'll talk about this. Okay, basically, when you factor this into its various forms, essentially you have the two numbers here, the a and the b and the c and the d, they're being multiplied and they have to equal 95, right? A and b are factors of 95. However, if you multiply this out, if you multiply these factorizations out using FOIL, you also have, here, 2 times a and then plus 3 times b has to equal 67. Same thing with C and D, correspondingly. So really, the two pairs of factors come from solving this system of equations. So an alternate way you could get the factors quickly and easily in Desmos is, now I'm going to use x and y just so I can get it to graph. So, okay, I don't see anything. Okay, now here we go. Perfect. Zoom out. All right, so here are my two solutions. All right, now, let's see here. What you have to remember is that the a value in my second equation is what's being multiplied by 2. Okay? So in other words, this a is really the x in the equation, and it's the same thing here. What's multiplied by 2 is the c, which is really the x. So the x coordinates are what I want here. So now you could just add 5 plus 28.5 manually and get your answer that way as well. But that's really kind of the theory, behind what's going on with this problem. Okay, next problem. This was a very common one that I saw as well. I believe I have this set up similar to how it was shown on the test, where you basically had a parent function, which is just a standard x cubed, and then you did some translations to it. You were given the graph after the translations, and there were 2 points labeled on the graph, and then you're basically told the form of this function here, this translated function, where there's a vertical stretch, there's a horizontal shift, and there's a vertical shift. All right, and I want to know what is the value of a times b, so this constant times this constant. All right, so unfortunately, you cannot just take, say, like these 2 points and go into Desmos and enter them in. Or if you were even to pick a third point, which I'll talk about in a little bit, even if you take that and you just go try to enter it in to this translated form, it generally does not work. So first I'm going to talk about some of the theory behind finding the values of b and c first, and also technically how you could find a. So I'm assuming that the way this graph was given is this, say in this example, this 4, 4 point is essentially equal to like the 0, 0 point for your parent function. Meaning it's the point where basically it switches, or technically where the concavity switches, where like it comes up, it goes almost horizontal, and then it, gets real flat, and then it goes up again. So in other words, what's happening here is it's going up 4 and it's going right 4. That means the C value is going to be positive 4 because of the upward shift, and it means the B value is technically negative 4 because it's going to the right. So it's going to look something like this. Now the question is, how can you figure out the A value? So at this point, I believe you can now go to Desmos and you could plug in the points. Okay, yes. And now you could do, now it basically tells you that A is 12. And now you could do basically 12 times, well, B is negative 4. So for this problem, I get the correct answer based on these numbers that I chose to be negative 48, letter B. Couple of things to mention. So the way you can figure out A from this graph without doing the excuse me, without actually using using Desmos or doing the regression, is that if you think of a standard kind of like parent function, it goes through 0 0 right here, and then you have essentially like 1 1, and then down here it goes through negative 1 1, and then it's basically like up here at 2 8, and then it's down here at negative 2 negative 8, right? Those are the points that this function goes through. So now the 1 1 point is what's being translated to the 5 16 point. All right, so we already know the x value is going 4 to the right, and we already know that the y value is being shifted up 4. So if we take, so the x value already matches, 1 moving over to 5. The y value, it's at 16. Take away the 4 from the vertical shift. Okay, so it's now at 12. So you now have the point like 5 12, that 1 1 is supposed to correspond to. So notice here, how do you get from 1 to 12? Well, basically you multiply it by 12. So that's really where the A value is coming from. One last thing just to mention about this. If you were able to recognize that, like, okay, you have this point up here, 5 16, and then I just want to see if I wrote it down, that there's going to be another point down here, which is going to be at 3, basically negative 8. Essentially here you go right 1 and you go up 12, to get to the next point. If you do that in reverse, meaning go left 1 and go down 12, you get this point. However, like I said, if you go to Desmos and you try to put in 3, all 3 constants, trying to figure them out, notice it gives these ridiculous values, and like, you can look at the graph here, like this does not look like a standard x cube thing. Like the A value is ridiculously small, like it's essentially 0, and then B is some gigantic number, and whatever. Like this is obviously not right. This is obviously wrong. However, I think if you plug in at least one of them, yes. It's like if you can figure out one of them, it will find the others and like give you what are supposed to be the correct values here. And actually, I just realized this I should do, sorry, this should be plus B, not, because the general form is plus B, not minus. All right, and then now you could do AB negative 48. All right, but without that, see, when I do this again, it does like switches these random values. I have no idea why it's doing that, why it can't match these 3 things to the, the nice integer value ones. But in any case, just wanted to highlight that as well. Okay, next up we have a quadratic function here. You're given one of its factors, you're given its vertex point, or at least an x-coordinate of it. You're told it passes through another x-intercept point. C and D are positive values, so what is the value of C here? All right, the easiest way, quickest, shortest way to figure this out is to recognize that since this is the factor, therefore the x-intercept point will be negative 7.75, 0. And then you have this vertex here, which is down here. So say this is whatever on the axis, right, at negative 7.75. You have a vertex here at negative 3.75, but some negative number. And then the other point's going to be over here, somewhere. And the key is the other point is symmetric, just in terms of its distance horizontally from the vertex. So notice what's happening here is, if you're at the vertex, you go 4 units to the left to get to this x-intercept. That means to get to the other one, you have to go 4 units to the right. Okay? Therefore, I'm at negative 3.75, and I go 4 units to the right. I end up at 0.25. So that's my answer. You can do 0.25, you can do 0.25, you can do 1/4. Either, any of those would be acceptable for C. Now, of course, you could go to Desmos and do this in Desmos. So what you would need to do is you need to make a table, and you have negative 7.75, 0. And then what you're going to do is you're going to do quadratic regression in vertex form. X1, it's minus negative 3.75, which means it's really plus 3.75. Okay, and then it's minus d out here for the y coordinate of it. All right, so notice this, obviously, it's not giving me anything. So what you have to do is you just have to pick a value for d. Let's just say I make it negative 1, okay? Now, it gave me the regression, and it gave me the graph, more importantly. So where's the other x-intercept? Well, it's right here. You can see you can click on it. It's this point right here. It's 0.25. Notice what happens as long as I keep d positive, meaning the vertex is under the x-axis. It actually doesn't matter if you make it negative. The x-intercept actually stays fixed because the h value of the vertex is fixed. Anyways, notice as I move this, graph changes shape, but where it crosses the x-axis does not change. It's still fixed at 0.25, okay, no matter how I move this. So that just confirms correct answer, 1/4, 0.25. All right, let's go to the top of the next page. Question number 4. Here we have an exponential function. Basically, you have the general setup of the equation here with some constants in it. It's increasing 14.3% for every 100 centimeter increase. What is the value of b here? Okay, so here's how you could figure this one out algebraically. Probably not the method I would use, but I'll just show it to you. Say we're going from 0 to 100 centimeters. I want to find the percentage increase, and I know that it's this value here, right? So percent increase, so I'm going to plug in, this is the old, this is the new. New minus old over old, and then times 100 to make it a percentage. So the new means I plug in 100 here, okay? And the a's are all just going to cancel out, but I'll write them for now. So it's a times b to the 100 over 100, b to the first. And then the old, you plug in 0 here. So that is just b to the 0, which is just 1. And then it's just times a. And now on the bottom here, the old is the same thing. It's a. Plug in 0 for x again. All right, so notice all the a's cancel out. Okay, now, sorry, this times 100 is equal to 14.3. So first of all the a's cancel out. You can factor an a out of top and then cancel with the one on the bottom, but regardless, these all cancel out, so this just becomes a 1. So now we have b minus 1, essentially, times 100 equals 14.3. I would divide this by 100. You could just, by the way, go to Desmos just to solve this. You don't have to do this by hand. So b minus 1 equals 0.413, and then add 1 to both sides. b equals 1.143. So this is the theoretical algebra way to solve it. There's your correct answer, 1.143. Now, what you could also do is basically go to Desmos and essentially just kind of like set this thing up, but fill in the values for it. So in other words, what I mean by that is I'm going to type this function, okay, like this. I'm going to say a is equal to whatever, 2. Doesn't matter what value you pick. Okay, then I'm going to do the percent change for, say, f of 100 minus f of 0 divided by f of 0. Then I'm going to multiply this by 100, and then this will be equal to 14.3. And then it solves for the value of b for me, and notice I get 1.143. So this is basically how you could mostly use Desmos entirely. You still need to know the percent change, percent increase or decrease formula. But notice right here, b 1.143. And then lastly, of course, if you recognize, because it says it increases by this much for every 100 centimeters, that just means when I plug in 100 for x, the exponent here turns into a 1, which means I need a number inside here which is equal to a 14.3% increase. That means you take 1 plus this value as a decimal, 0.143, and that just becomes 1.143, which is the answer. So that's the pure theoretical approach to it. So if you recognize that, that's the quickest and fastest way, and you can just figure it out, by doing that. All right, next up, question number 5. So here we have a cubic polynomial with 3 roots. Okay, this one is actually pretty much like a brand new problem. I mean, it uses some of the same concepts that we've talked, that you've seen before, they've tested before, but nothing exactly quite like this. So, all right, basically what's going on here is you have an x-intercept at negative 54 coming from this factor right here. Also, since it says that this is divisible by x plus 45, that means there is another x-intercept at negative 45. Okay. Also, I guess I should actually draw this out on a graph here, but say here's negative 45. There's one of them. Out here at negative 54, here's another one. Okay, at negative 50, the graph is positive, i.e. the y value here is greater than 0. Then at negative 48, the graph is negative. So down here at negative 48, it switches to negative. Okay, well, what does that tell us? That means it's going to cross, somewhere between negative 50 and negative 48, and it specifically has to be negative 49 because it tells us that this value is an integer. So that's the only possibility between negative 50 and negative 48. So my 3 x-intercepts are negative 45, negative 49, and negative 54. What is the maximum value of c? I.e., what is the largest value of c? Or in other words, what is the largest x-intercept value? Well, it's going to be this right here, negative 45. And that's it. Which one of these is to the most on the right on the graph is another way to think about this. So correct answer for this one, negative 45. Okay, next problem. There was one on a previous test, I don't remember the exact month now, but I looked it up, which was very, very similar to this, except it had a y in it. It did not have, it had a p, but it didn't, here it had a y instead of an x. So the equation was a little bit different than this one, and the setup and solving is a little bit different too. So I thought this was a repeat problem initially, but it turns out that it is not. Okay, so let's take a look at how we solve this one. You have a quadratic equation. You're told p and w are integers. You're told it has exactly one solution. Which of the following cannot be the value of w? What that means is, for 3 of these 4 answer choices, you can make exactly one real solution. For one of them, you cannot. All right, so let me just look at my notes here, because there are 2 different ways that I found to do this in Desmos. What I thought was the quickest, fastest, easiest way is using the derivative approach, derivative method. So what that means is f of x equals left side, g of x equals right side, and then type in this whole long thing. This is basically a technique or an approach that you use in order to force exactly one real solution between the left side. Essentially it's like two equations now, like y equals left side, y equals right side. You're forcing exactly one real solution. Okay, so notice here, it didn't give me one of the four answer choices, but that's fine because all I'm going to do is now I am going to type, for example, w equals 91. Notice I get an integer value of p. That means this is not the answer to the question. I can eliminate it and move on. All right, next one. 126, another integer value. Again, doesn't have to be positive. It can be negative. You know, that part's irrelevant, but eliminate it, move on. 286, still get an integer value. Looks like it's going to be d, and it is right here. Notice p is not an integer. That means this is the correct solution to the problem. W cannot be 308 because then that forces p to not be an integer. That's what I think is the quickest, fastest, easiest way to do this. An alternate method that you could use as well, which is still basically like testing the same concept, same idea, is to find the discriminant. So 4x squared plus px plus w minus 90, which would be b squared minus 4ac. Basically, set that equal to 0, and then you're going to check the p and w values as well. So this would be p squared minus 4 times 4 times w minus 90. You tilde that to 0. Okay, and then I'm going to go through and I'm going to check each answer choice. So the first one was 91. Okay, notice I have an integer value of p, not the answer. 126, integer value of p, not the answer. 286, integer value of p, not the answer. And here, 308, non-integer value of p is the answer to this problem. Those are what I think the two fastest, quickest, easiest methods to do. I'm not going to bother like doing out a bunch, you know, I don't know if there's a bunch of algebra or whatever you could do to check this, but that's how I would solve this question. Okay, top of the next page, question number 7. Here you have one where you basically have two different types of things. In this case, it was tomato plants. One of them had weight ranges of 9 to 16 pounds. The other one had weight ranges of 22 to 26 pounds. You're told the farmer wants to grow at least 766 pounds of tomatoes, and he has planted 18 plants of type A. What's the minimum number of plants for the other type he can grow to make sure basically he gets at least 766 pounds? All right, so essentially what you need to do here is you need to take the 18 plants for type A and you have to multiply them by the minimum possible weight for type A. You basically need to do this as like essentially as cautiously as possible. So the minimum pounds of tomatoes you get from type A would just be 162 pounds. Subtract that from the 766. Okay, that means he needs at least 604 pounds of tomatoes from type B. And now, if we want to know the minimum number of tomato plants, okay, again, we have to assume the lowest possible yield, which would be 22 pounds for each individual plant. So we take this, we divide this by 22. Notice it comes out to, I get 27.45, but technically you have to round that up to 28 because first of all there's no such thing as like 0.45 of a decimal of like a plant, and second of all, if you round it down to 27, you would not reach the 766 essentially. So the correct answer for this one is going to be 28. And another alternate way to think about this is basically if you want to set up inequality, really the way it looks like is this. You have 9 pounds per plant times 18 plants, that's from type A, plus the minimum 22 pounds per plant times X plants for type B, and that has to be greater than or equal to 766. So you could just go to Desmos, you could type this out, solve the inequality. And then when we zoom out here, notice it's right here. It starts at, again, 27.4545, so you'd have to round up to 28 and get, the correct answer that way. All right, let's talk about another common question that came up. This is the one where the person invested something for a certain amount of money for like some period of time, 4 months, 6 months, whatever it was, and it increased by a certain percentage over that time. And then a couple months later, the amount of money had increased by an additional percentage from the original amount, and then it continued to increase by that same percentage every, 2 months after that. Okay, and it says, which of these equations here represents the amount of money in the account, X months after the account was opened? And they all look pretty similar. They all have the same number, out front for your exponential, your net starting amount. They all have the same base here, but the exponents are what is different. All right, so, okay, a couple things. First of all, what's going on here is we start with $700. The initial interest rate is 0.4%. So that means, if you set this up as an exponential, it's like 1 plus 0.004, or in other words, 1.004. So the amount of money earned after the initial amount, after the initial 6 months, is 0.4%. Okay? So 700 times this comes out to 70280. So that's where the number in front is coming from. All right? Basically, like the 702, essentially the 70280. Then, basically every time period after that, it's increasing by 0.2%. That's why this number here is 1.002, because it's 1 plus 0.002, 1.002. Okay. So now the question is, which of these exponents is correct, essentially? So the easiest way that I've found to do this is to just essentially back solve it. So what that means is, okay, let's say it's been 8 months. Okay, so after 8 months, you would have this amount of money, which would then have increased by 0.2%. So in other words, you would take this and you'd multiply it by 1.002. And when you do that, your total expected money would be 704.2056, right? 704.2056. So if I go to each answer choice here and I plug in 8 for the number of months, the one that gives me this number is going to be the correct answer. Okay, so they're all going to be the same. It's just the exponent part that's changing. So, and I want to check f of 8. Okay, so the first one, clearly not correct. All right, now let's check b. X over 2 minus 6. Notice this one actually decreased, so okay, that's obviously not correct. If I check this one, notice this is not correct. I don't have 704, so it looks like it's going to be the last one just by default. Get rid of all this, and yes, notice it is. Notice when I plug in 8, I get the same value that I expect by manually calculating a 0.4% increase followed by a 0.2% increase, so that has to be the correct answer. So the correct answer for this one is just going to be letter D. Now, last thing, just to explain the theory behind how or why this is the correct answer. So basically, the way that all these are set up, right, the 7082.80, that's already factoring in the 4% interest earned over the first 6 months. So that's kind of like the starting amount, at the 6-month mark. So then, essentially what this is calculating is, what the increase is every month after that. So the point is, if you say you want to find how much interest there is at the 8-month mark, right? Well, it's not just going to be like raising it to the 8th power, or even like 8 over 2, because it's every 2 months, really 8 every 2 months that it accumulates, because at the 8-month mark, it technically would only have gone through one 2-month accumulation. You know what I'm saying? In other words, you want it to be raised 1.002 to be raised to just 1. So the way you account for that is you have the x over 2, which is like the number of months, divided by 2 because it's every 2 months, but the minus 6 over 2, that is subtracting essentially the original 6th month period where you already factored it in to the starting amount out here. So like normally the way you would see this problem would be just like this. Say you started with 702.80, every 2 months it increased by 2%, and you wanted to say how much money do you have after X number of months. You just plug it in, divide it by 2, and then do the calculation. The problem is you have to subtract it down, because even though, like I said, if you're plugging in 8 for the number of months, really it's only been 2 months that interest has been earned at this lower 0.2% interest rate. So that's why this minus 6 over 2 is here to reduce, say like the 8 over 2 down to 2 over 2, which is just 1. Okay, so that's why it looks like that. All right, next question. We have number 9, another exponential problem here. And this one is asking how much is this function increasing by when x is increasing by 8? Just by 8. So we can use the same percent increase, decrease formula that we've seen previously. So what I would do is I would just put this function in Desmos. And then I would say, okay, new minus old. So the new is going to be, say, it's increased by 8. So I'll do f of 8 minus f of 0 and divide it by f of 0. And then multiply that by 100 to get the percentage. And therefore, it's going to be 44%. That's our, that's our answer right there. Essentially what's happening is, every time you increase x by 8, this 1.20 is being squared. And so when you do that, 1.2 times 1.2, you get 1.44, and that just corresponds to an 44% increase. Subtract 1 from it, 0.44, that's the decimal, that's 44%. So that's just an alternate way, basically, to think about it as well. All right, next up, question number 10. So this problem I had found previously, but I didn't quite have all the details correct. And now, basically I got more details, so I know exactly how it's set up. So now I know exactly what's going on with this question where this person's going biking and running, and essentially there's these restrictions of it has to be at least 25 miles total, but it can't be more than 3 hours. All right, so we're going to set up two inequalities here. The first one is going to be x plus y less than or equal to 3. That's the max amount of time he can do biking and running. Then the second thing is going to be the distance, when distance is basically rate times time, or speed times time. So his rate for running is 7.5. The amount of time is x. Biking, it's 11.5 times y. And this is, let me just make sure I get my signs right. Okay, this is the one where it's at least greater than or equal to 25. Okay, 25 total miles. So now what I would do is I would go to Desmos and just graph these out. Okay, and so first of all, the solutions, any solutions to these are anything where it's shaded. You know what I mean? Meaning the overlapping region, this small triangular sliver like in the upper left part up here. Okay? But we want to know what is the minimum amount of time he can spend biking. Okay, so biking is y. Biking's multiplied by 11.5, so the amount of the biking time is y. So what's the point with the smallest y coordinate that falls in the solution set? So it looks like it's going to be right here, 0.625 hours. So therefore, which of these is closest to it? Well, it's going to be, essentially letter B. Now, technically, zero point 0.7 is greater than 0.625, but that's fine because notice if I set a line here, so notice any of these points in here where the y coordinate is 0.7 fall within the solution set, meaning that it's less than 3 total hours, but it's at least 25 total miles completed. Okay, so that's it. This is the problem. This is how it's supposed to be worded, so correct answer is letter B. All right, the next question. This one, I'm not 100% sure of what it was asking for, how it was set up. I mean, I got most of the information, but the thing is, I did not know how the answer choices were structured exactly. Like, if it was a free response looking for numerical values, or if there was something else with like P's and R's in it. So this is the way I set it up. Basically, I set it up that there was a point on one line, another point on a different line. They have P and R's constants. What's the value of P? All right, so what I did is basically plugged in P and R to each of them. And then I went ahead. We basically have a system of equations here that we can solve. So I basically just went ahead and let's see, how did I do this? I guess I did this by substitution, but we don't need to spend all the time doing that, honestly. We can just go straight to Desmos and we can just solve this in Desmos. Now, I have to use x and y if I'm going to use the graphing approach. Okay, so let me see. Yep, so right here is my solution. P is equivalent to x, so therefore I got the answer of -12. If you wanted to keep it in terms of P and R, of course, you could solve the system of equations using regression, and then we would just type in 2P plus 3R, comma, 10P plus 11R, close that list, open a new list, 12, comma, 12. There's P, there's R. That point, -12, 12, is on that line, and the other point is on the other original line. So that's it. I'm sure there's other ways you could do this algebraically to figure this out, but I think it's just much faster and easier. Just set up the system of equations, plug the point values in, and then just go to Desmos, get the answer that way. All right, let's talk about this next question, number 12. This is one that, again, I thought was initially going to be a repeat question, but it's actually slightly different than the previous versions. Previous versions have typically, there's one that asks about like partial circumference. There's one that related like the angle and the radius of the circle and the arc length. Find the measure of the radius is what was asked. This one is a little bit different though, because basically what's going on here is we have the circle, we have its center. We have 2 points on the circle. So here's point A, here's point B. We have the measure of this arc. We're told it's 24 degrees. And we're also told its length, which is 5 inches. Now, you don't really necessarily need this for the problem, but here is the central angle that corresponds to it, which is also 24. So what's the circumference of the circle? All right, so this is actually a just really basic proportion problem. 24 degrees is for this arc, right? Total circle measure, 360 degrees. Okay, so 24 arc out of total circle. It's going to be proportional to the arc length, 5 inches, out of the total circle length. Well, that's just the circumference. So you just go ahead, solve this equation. Cross multiply 24c equals 1800. Divide by 24. C is just going to equal 75. So therefore the circumference of this circle is just 75 inches, and that's it. All right, last question we have here, top of the next page, question number 13. So this is actually a fairly straightforward, fairly easy quadratic question. You have two constants, you have 2 points, so you can just literally just go to Desmos, put in the 2 points, put in a quadratic regression, and you get the value of b here as 4.4, and that's it. Now we could also enter it as 22 over 5. And of course for this, like if you want to solve this manually, I mean you could do that, that's fine. Notice if you take this point first and plug it in, you get 0 plus c is equal to 3. So that tells you c is equal to 3. And then you plug in the second point. So we get 0 equals negative 5 squared plus b times 5 plus 3. This is 5 squared 25, and then the minus sign makes it negative, plus 5b plus 3. These two are negative 22 plus 5b. And then add this. 22 equals 5b, divide by 5. b equals 22 over 5, or 4.4. So that's it. All right, so I hope you enjoyed this second March 2026 Digital SAT Math official test problem set worksheet and video. If you did, please give this video a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you haven't done so already, check out the solutions to video worksheet number 1, and also check out the video for the repeat problems. Basically, it's video and worksheet number 3. If you have any questions or comments or alternate solution methods, please feel free to leave them in the comment section of the video below. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are 2 versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants and the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.